so much. So good morning from my side. I'm happy to have the starter here. It's actually a topic which maybe goes a bit of beyond what I had heard yesterday from the discussion, where we have a lot of discussions about technology and battery and so on, what's ongoing. So my role myself, I'm from Bosch. We are doing automotive control units. We are market leader. And I'm head of software engineering in that context, and we are looking at battery management systems. We are looking how to connect them to the cloud, digital twin, how to bring that forward. And maybe that's a good starter, because what we see, you can't solely think of a component anymore. You always have to think together with the digital representation of a component and how to monitor and how to bring that forward. And for that, I would like to give you a pitch here, how we look at this world and how that comes together. So this would be the journey throughout my talk. Start with this idea, this buzzword of a software-defined vehicle. Then we go to the topic of battery management from our side, connected services, and then how we connect it to the cloud and how AI helps us in that context. We yesterday already had an icebreaker session toward that, which brought some kind of interesting insights. Software-defined vehicle. So as that, you cannot think hardware solely alone anymore. That's our view, at least, right? We experience that heavily concerning if we look at smartphones, whatever. You always have something equipped with that, and think of how not only you have your component solely managed, instead how can I equip it with functionality I have for software to update, to upgrade, to manage the life cycle of a system. That's a basic idea what we see for software-defined vehicle. The idea is to increase by that the user value with that. And for instance, one very prominent thing, and I think that's especially necessary for battery systems, we enable by that to monitor the vehicle health. How healthy are the components within the vehicle? Yeah? And I mean, having as Bosch a lot of history in combustion engine for centuries, right? It's now basically about having a more newer technology in the automotive context. You need to monitor much closer, right? To know what's happening out there, because there is typically a different behavior out there in the streets compared to what you assume in your laboratory when you build a pure product. Yeah. So this helps a lot, and the idea is to really go it over the lifespan of the vehicle, so to keep features, to upgrade features, so that's the basic idea. But this needs to have the right level of abstraction. Clearly, you can optimize, squeeze out any kind of cent of cost if you try to do a two-point design, right? But this two-point design typically leads to the point that you keep out any kind of chances to upgrade your functionality. So you need to write abstraction, and this abstraction is not only for one supplier or one OEM or one battery component. It's about we need to develop towards the industry to fund this common layer, because this is not specific for any kind of point. And what goes along with that is basically also the way of collaboration, right? I mean, one very prominent word what we see is about the topic of China speed, right? And this is that it's no longer this traditional supplier purchaser relationship, right? You need to co-development, yeah? And this is a point we really need to learn, especially from my perspective in Europe, yeah? To jointly develop further of the products, yeah? Also towards the maturity of the project. I think that's an important part where we would like to go. And this leads from our point, and this is just pitch how we see basically the abstraction going upwards, right? So you really need to separate the point to have a flexible hardware, right? Which you need for the different kind of use cases you would have to into place. Then it's about, we see that there's a lot of heterogeneity on collaboration models. We have tier 2s, tier 3s bringing their software in, OEMs bringing their software in. You need, especially for battery management, you need to separate what is a basic steering of that and health monitoring versus what is a basic self-battery specifics. Yeah, so you need to encapsulate that, and I mean, we as Bosch try to be a supplier in that sense that we have some kind of platform, yeah, and we don't need to reinvent them. This is our point, how we try to serve the market, right? Have a chance to most fast and most efficient bring solutions to the OEMs at that point and bring the parties basically together, right? And this does not end in the vehicle. What we see clearly is a point, this connection to the cloud, which is an essential part, right? Where, especially in the automotive industry, we are still yet on a learning path, to be very honest, yeah? And what is more important, and I will step to that in a second, is we are yet have to learn how to collaborate, especially on a software level, right? Because we used to apply from the past the component-wise collaboration also on the software, which hinders us to gain up the speed what we need. And for that, I just cite here out of the we.CONECT software-defined vehicle trend report, right? I just cite the statistics what out of there, where we basically see that currently, as feedback to the participants in that study, we see that there is a barrier in that collaboration to have a proper software architecture here in place towards all the testing topics. We also had a discussion yesterday, which is one important point, and also towards recovery mechanisms. And also to ensure in that context, and this is beyond that, what I will come in the end of my talk, also looking at new technologies like AI, where there's a lot of hesitance to apply them because these regulations are not clear, where to use what and so on, yeah? And especially if we look at that point, you see that worldwide you have also different regulations, and as a worldwide company, this is a point where to work at this end. Second compilation of these studies, basically, currently the market has no clear trend towards EE architectures, towards technologies, and so on. Yeah? So we see a lot of heterogeneity out in the market. Each OEM tries to find their preferred way towards the setup of their architectures, and this requires from us to have high flexibility at this end to serve this market, basically, yeah? If we would like to have reuse and don't to reinvent that basically overall. And finally, it's about the tool chain, right? We see that this collaboration is key, and this is perceived as the main pain point in the current setup, yeah? We have difficulties to collaborate in a fast way. From traditional combustion engine, we have these 3-month cycles where we do updates, right? We are now talking about weeks, days having updates, yeah? And this is something which is not possible with our former setup at this end. Good. And this basically brings what we, for instance, see as what we call customer front end, where we have a platform to really collaborate directly. Both parties can share their software, can trigger, can plan their software, can basically execute, can upload, can test, and so on. So we need platforms like this, right, to really enable this collaboration, yeah? And this is not restricted to software. You need to align with the requirements, also what is fulfilled, to have transparency if both sides evolve fast. And from my perspective, this is a very core of an agile development, to have the proper platform and transparency where you are, that you can collaborate on this end. Here, just touching to that, if you need any more information, I'm here for the next days, we can talk about that. Now looking at the topic of battery management, I mean, Bosch is doing a lot of components. I could have put the inverter here and so on. I mean, we have this set of components all out of there. Even so, we are not doing batteries, right? For instance, we are just doing the battery management in that context. And this is what I would like to focus on, ping to the point what we see. It's not yet even clear where in the E architecture this topic is placed. Yeah, we see maybe different kind of mergers. We have the different kind of functionalities coming in. So if we talk about battery management, which is basically about really controlling the battery in its execution, you additionally need this battery disconnect in case, for instance, of an accident or anything to manage that. And you need to basically supervise the circuits in here to being forward. And we see that we have integrated versions where topics come together. We get requests of distributed versions, right, in the architecture. And this requires a flexibility in the hardware, basically, at this end to be in there. And for that, also the scalability. I mean, we have a history in 84 volt, yeah, but this goes now up to 1500 volt. We have even industry applications requested right now. So this is a huge scale. You need to be flexible in the software and don't reinvent everything right away, right? That's a bit of the challenge, how to bring it together. And besides that, we also see that there's a request coming in to combine that with other functionalities like charging, bring it directly together, like with a charging communication which connects to the charging station, right? Especially if we think about future to have bidirectional loading, right? Also going towards that. So there are a lot of challenges coming around that. What we see that there is a high flexibility required, and so far we don't see any main trend, to be very honest. Yeah, looking at the worldwide market, even if we look what's happening on in China. And this basically brings from what we derive out of that, right? It's about flexibility in software side, different stacks from different parties to be involved. We see this software collaboration. We see this modularity in hardware. I mentioned about that. No clear mainstream available. We have distributed setup, CSCs partially integrated, partially separated, and so on. So have the flexibility in there. And you need to think right from the beginning all safety and security aspects with that. If you would try to design that later into the system, we see basically that this is a point where we typically will fail. Finally, it's about the ecosystem. A set vehicle is no longer on its own, a component is no longer on its own. You need to connect it to the cloud, which is basically the topic I would like to focus in next. Connected services. So it's not only a field restricted to EVs, we see that from all kind of vehicles coming in. And it does not start only vehicle in the field. We start with a topic very early. Yeah? So one topic is to have these data which we collect basically used in design optimization. Pretty often you tend to, at least if you're Bosch, you tend to over-design, right? Because you would like to good on the reliable side. But if you have field experience, right, you can use it in your design, right? And maybe do more appropriate how it's basically used, right? Then about the validation in the different scopes, right? And then looking at the field management basically. And finally, if products are on the road, we can basically talk about the topic of having here cloud diagnostics, right, vehicle health approaches and so on. And finally, it's about the topic of certification. Yeah, so to having some kind of validation, in what shape are your components at this end of the vehicle when you buy it. Today, even with a combustion engine, sometimes a surprise what you get if you get a used car. And it's even more difficult if you look about an EV, right? Because the battery is the most expensive component, right? And you would like to know what's the state of health of that, right? How is it working, basically? Yeah. Clearly, one challenge in the topic is the topic of data access. We also had that yesterday evening. And we see there completely different approaches, Europe compared US or Asia, right? Europe pretty restrictive that. I think we will learn, yeah, what is the benefit of sharing data, what data and what not, yeah. Currently, it's pretty restrictive to get there forward, also to be honest. Good. And for that, we are basically, as said, it's not only battery. I will now focus on battery in the next slide, but we are having there some kind of bunch of services, what we offer around that. As said, especially for technologies which are pretty new, we see a lot of benefit looking how they behave in the field, right? Because you can learn a lot of that and not only get those outliers back which are not working anymore, right? Instead of getting directly monitoring of the field. We're just doing the same with our fuel cell approaches, right? So because it's pretty new as well, right? And there we just apply the same, but we design it right from the beginning into the systems to monitor the right data out of that. And this leads to our product. What we have in battery in the cloud, which we have already at several customers running as well. The basic idea is that we have a flexible way to do the data acquisition in the vehicle, right? So this is on the very left. You can even update during the lifetime of the vehicle what data to acquire out of that vehicle, right? And that's possible without having any kind of impact of certification or anything. So you directly can pull the data out. Then clearly you need to have prepared some kind of digital twin of your battery, yeah, to associate the data in the right context. That's the important point. And this allows to adapt also strategies, for instance, towards charging strategies, how to improve the lifetime of your vehicle, right? So that's basically the way back, yeah, to also give feedback to the vehicle, how to optimize, how to improve at this end, to retain the value of the vehicle in this end, yeah. For that, I mean, we basically have machine learning models. We are now going a bit beyond to analyze the data we have from the vehicles, to detect anomalies, to compare to others, right? To see where is something and a behavior ongoing, what we see which might lead towards a critical behavior. Which leads us basically here forward. And this is about then the topic of what I mentioned, it's aging prediction, right? It's about the usage certificate, what we also in alignment with the VDA to define how to basically come to such a certificate. And it's about the lifetime monitoring, how that goes on. And this is basically having transparency of your state of health of the different components, clearly here in the focus of the battery. But this is something to plan right from the beginning, right? To have this come in view on that. That's a basic point what we are looking at. Good. Then let me close how AI comes into the topic, and then I think we have a few minutes for questions. On the one hand, we see AI basically, first of all, two sides. One side I have completely left out here. We have huge acceleration towards development speed by applying AI technologies. Yeah? There we see a real boost getting forward. What I try to focus here is basically having AI in our product. And there we basically have 2 points, right? One is within your vehicle, where you're pretty much restricted with your computing power, right? Even if you might have processors, but it's still limited, right? Yeah. There we see that it is possible to speed up a lot, to gain flexibility by not any more programming functions in a physical way, solving them. Instead, we are using neural networks to do that. We train them, we bring them to the point, and this basically helps us with our embedded library to learn machine learning, right? It's a deterministic model how to behave in that point. So this is what we bring forward, which is also already in series to show that we have this available in even safety critical systems to get a predictive model here and there. And for the off-port part, it's really about more to use that big set of data, what we have, to analyze in the right way, to compare it, yeah, to see where is something happening, to get an early indicator for the vehicle, where it's getting forward, which brings safety for the car owner, which is for maybe a fleet manager, for the OEM, and also for the suppliers who are in that contact. And for that, my proposal is we should also share this data, have transparency on that, because we only get the speed for this new product running if we closely together look at that, what's there, and get best out of the result of that. That would be my pitch. Thank you for listening, and happy to get a few questions. Even so, it was a hard start in the Monday morning, and happy to get your insights on that. Thanks a lot.
So thank you very much. So for the Q&A, if you have any questions, you should come here to the microphone. So then when we record the presentations and you listen again the presentations, you will understand what is the speaker answering about. So if you have questions, you can come here.
Nobody dares, right? Yes.
So here, hi, I'm Prashant Vemireddy. I'm from Hero Tech Center, Germany. So I was wondering about the hardware itself. We were talking about not accelerating the hardware itself and using these models and libraries to make them function better or bring the optimization. Are we talking about the current generation hardware, or are we talking about the dedicated chipsets for the automotive industry, which are coming in the future?
I mean, for now, we have to work with that what we have. And we are currently learning, is there something specific which would bring us forward for the battery management? So far, we see there is no blocking point in using the current technology. And as you know, designing specific hardware is pretty much invest a lot of cost in that, right? And especially in these unsecure times, we see it, and there's no main trend, it's a bit difficult to see, right? We see that some share of the models, there is an interest to do it calculation in the vehicle. For that, the typical opportunities or capabilities we have are pretty much limited, right? On the other hand, and this is what I also see, if you look a bit smarter on that, and if you try to somehow reflect that in a way, like for instance, a neural model, you can go much towards that. I mean, embedded controls is always about living with the limitation you have and squeezing the best out of that, right? That's a bit of the trade-off. But what I've seen so far, even there are a lot of talks about doing centralization and on one computer and whatever. I think there's still a bit of a split. We will definitely have an increase of centralization that is there, but I think there's still a limit what I will integrate in central machines and what not, because so far all microcontroller-based technology is very much controlled. We know how it works, we can analyze and so on, and having the processor side in that place gives limitations. So we will have a clear split, what to do where, right? And this is something what we will learn, but so far no clear trend, and for that having a dedicated investment is yet risky. That's our view actually at this point.
Okay.
Yeah.
I'm a bit surprised to see that as well. It was not a centralized architecture, and some of the things you have mentioned were more on the decentralized or the conventional way of doing things.
Yeah, I mean, as said, it's a huge share of that, but so far this big trend towards centralization, we see a bit of a rollback, because having these several component units is pretty expensive compared to the classical ones, and for that it's yet a still hesitance to go. I think we will go there, but it's going slower than we've expected. That's what we perceive.
I have one more question.
You're welcome.
Validation of these systems. Do you see that we need to step up the validation game because when we work with such models, we can restrict as much as possible how we see the outcomes of it. But there could be ways that we don't know how they are functioning and what kind of outputs they bring. And validation.
You mean the AI models, right? Yeah. Okay. Right. I mean, that's a bit of the point. AI is a huge word, right? But if you start at the very bottom point to do machine learning, pretty saying, I train my model with specific inputs to produce specific outputs, that's pretty much deterministic and you can work with that, right? We are not using Gen AI to do anything in that. That's what we're not doing. So for that, you need to apply the right level and then you basically can work with that, right? Yep. Good.
Thank you.
You're welcome. Yeah.
Yes, thank you, Jochen. Yep. Thank you for your presentation.
Thank you, guys.